So I get to give the part of the presentation where you actually get to see some slightly interesting pictures. So I'm going to talk about some new standard drawings that have come out in about the past year and a half, and then I'm going to go into what we're working on to implement the design changes that you saw and some additional detailing changes into the pre-stressed eye girder standards. So the new standards I'm going to go over are these four listed here. And then, as I mentioned, we have been working for about 2.5 years to implement all the changes that have happened in the Bridge Division recently. If you are familiar with our webpage, the eye girders is the largest portion that we carry there, and it comprises, actually it's more than 210 these days, but it's a lot of DGNs. So the first two here are miscellaneous slab details and thickened slab bank details for steel girders and I-beams. And you might say, didn't these exist before? And you'd be mostly correct, they did. They were just called the SBMS and the SBTS, and you could find these in the miscellaneous portion of the website, the very, very top portion. What changed in these is that, and the statement's just slightly wrong, I realize, it doesn't reflect the empirically reinforced deck. You still have to decide when you're doing a steel girder design what the reinforcing in your deck is, but what it has done is it's going to make the reinforcement match what's in an empirically reinforced deck, and that'll make sense when I get further into the presentation. And you'll be able to use these two drawings in tandem with the IGMS and the IGTS. The former drawings were done for an 8-inch slab, and they were to be used on any type of steel, girder, beam, whatever was going to be used. And what we ended up doing is taking those two drawings that used to be up on the top. We did very, very minor, I think like title block changes, and we moved them down into where the steel beam standards are. We replaced it with these two new drawings at the top that are intended to be used predominantly with steel plate girders. And again, I said the main reason to do that was because we're making lots of changes to the eye girders. So if you're doing like a direct connector where you have text girder approaches and then curved steel girders, you've got these drawings that work together. Stone riprap. This is a new standard we put out, and the reason we did this was to take the graphics that were formerly found in item 432 of the spec book and put them into a standard drawing. The idea when the spec book was coming out for 2014 was kind of to get some of those graphics out and put them where they really belonged in standard drawings, so that's what we did. The first page here was put together to really kind of mimic what you see in the concrete riprap. We provide the elevation and the plan view and a little connection details. And page 2 is really those graphics just straight out of what used to be in the spec book. So these days you now include a standard drawing if you're going to have stone riprap on around your bridge approaches or slopes. And the last one's really kind of neat. We put this one out in July, just this past July. It's called the GFRP, and it is GFRP reinforcement for a bridge slab. It was designed based on this guide spec from AASHTO. And what is it exactly? Well, it provides the details for just the top mat of reinforcing in your deck, and that's reinforcing for GFRP. It is intended to be used in the portions of the state where you employ the corrosion protection measures that are prescribed and you'll find on our webpage. And this drawing really provides generic details, whereas if you look at a span drawing in the text girders, it's for a certain roadway width, it's got the number of beams laid out. We did this one in a generic sense so that it can be applied to any span drawing. So there's no roadway, no beam spacing. What you get is the design information is provided in a table, and I'll show you that here. This is the first page, shows the plan view for our non-breakback spans and then gives you the typical sections. This reinforcement is to be used with a PCP, and this drawing is specifically for an 8.5-inch slab. The second page shows the span with a breakback condition, and here's that generic design information table. It lays out how many bars, or the bar spacing based on the girder spacing that you've got. So your question is, how do I use this drawing? Well, there's two basic ways that you're going to use it. You're going to include it as an option in your plan set if you are specifying epoxy-coated reinforcement, that primarily if you're in the corrosion protection measures area, or if you have another reason that you're specifying epoxy coating. You're going to detail the bridge just as normal. If it's a standard bridge and you're just pulling a 28-foot roadway and that's what you're going to put in there, you just pull the IGFRP sheet and you throw that in there also. The contractor gets to choose whether they're going to supply epoxy-coated or GFRP bars. The second is if you specifically want to have GFRP bars in your bridge deck. In this case, you would use this standard drawing as your guide to prepare your actual span sheets. You would not use the you not include the IGFRP, but you make your own details. Some reasons that you would do this, maybe your district just doesn't really like epoxy-coated reinforcing. You've had some bad experiences with it. Or other reasons, it's been used around Austin, specifically on our toll facilities, because the toll booth area needs to have non-conductive reinforcement in it. So that's why they're using it in those regions. Okay, moving into eye girders. And a lot of this, you've seen what Jamie presented, but I'm going to show you how we've actually implemented. So we've captured the design changes of our 8.5-inch deck with the 2.5-inch top cover. And the reason we did this was kind of twofold. One, it was to improve durability of decks all across the state. And we actually did a quick poll of our bridge engineers around the state before we chose to do this and said, does anybody really bother that you've traditionally built an 8-inch slab and we're asking for an 8.5? And they said no. Not a problem, sounds great. And the other one that I heard comments about was for those in the corrosion protection measures, you always had to go through this little checklist of things to modify on the standard drawings in order to satisfy corrosion protection measures. So you no longer have to do that. You've got all the corrosion protection measures built into the standard drawing. You do still have to include in your general notes things such as your epoxy coated or your HPC, but you don't have to do that on the standard drawing anymore. We have put the empirically reinforced deck into our text girders. And other notable thing, maybe not so apparent to you all, but this is the first set of beams that will be designed in PG Super. Everything else up to this point had always been done in Pre-Stress 14. So PG Super, we capture all the new design provisions for our pre-stress girders. Detailing changes, this is where we had a lot. Took the most time to actually get done. We are now doing clear cover and out-to-out bar detailing on everything in the text girders, and that's just to follow industry practice. Building practice does this, and pretty much all other bridge detailing does too. We are moving to grouping all our notes into their kind of specific areas. We've been doing that on a lot of other standard drawings, so we finally implemented it here. On the span sheets, we're showing the PCPs in cross-section. That's because we do 80% bridge construction with PCPs, so that's what we want to show. We removed the Class S concrete from the EQ table. We asked our contractors about this before doing it, kind of had mixed results, kind of lukewarm about it. They said for the most part those quantities aren't actually correct when they get out there and are putting their beams up in the field, so we had no heartburn going ahead and removing those. Bars A and T are reversed, and that goes with our empirical deck, the new size of bars and spacing. But we flipped the bars because the type of cracking that we typically see in our bridge deck, and we're small cracks, very small and tight, but the change in orientation of the bars better helps control that cracking. When you get to the abutments and vents, we changed what was typically equal spacing into max spacing, and I'll show that here in a moment. We are taking the column to 1 foot below grade on all structures. And finally, it used to have a difference whether it was at grade or it was a stream crossing, and I'll show you that in a moment. We've changed details of our spirals a little bit too. So these all seem like fairly small changes, and they are, but really they have some big impacts on our drawings. So here's the empirically reinforced deck, as Jamie explained also. We're putting both bars A and bars T as number 4s at 9 inches. And to do that, you have to put some extra capacity in the overhang for the bridge rail and potential impacts. So you have these additional OA bars spaced in between the transverse or at your overhang. Again, 8.5-inch slab with 2.5-inch top cover, and there you see that the bars are reversed. We show our PCP, and we're also not showing the thickened slab anymore. We didn't feel that it was necessary to continue detailing a thickened slab bank here and then have a whole separate standard drawing. Now, don't be alarmed if there's a reason that you are not going to be using a PCP or your contractor elects not to. We're continuing to provide the bottom mat reinforcing details. It's just that we've moved those to the IGMS, the miscellaneous slab details. So they're not gone, they're still there. Okay, about this equal spacing thing. On the left you see is how we formally would detail this. We would tell you that we would tell the contractor that they needed 10 equal spaces across a certain distance. And now we're asking that it be detailed giving a maximum spacing. So the equivalent here is 10 spaces at 8.5 inches max for 7 feet. And why did we do this? Well, in the old, if you had 7 foot, you divided it in 10 spaces, you had an 8.4-inch spacing. What is 8.4 inches when you're out in the field? 8.5 really is what it is. That's the way that the steel tire is going to tie it up. But we've heard from steel tires that there were a few inspectors that were rather particular about getting their 8.4-inch spacing. Unfortunately, that precision it's just meaningless. It doesn't get us anything. It's not a better bent cap because of it. So this is 2 examples of spacing that would be acceptable in the field, would satisfy our 8.5-inch max. Make 9 spacings at 8.5, and then your leftover is 7.5, or put 8 spacings at 8.5, and then you got 2 8-inch spacings. Both of those are perfectly acceptable, and they satisfy what the design is intended for. Here's that 1 foot below grade for columns. Formerly, it was 6 inches at grade crossings and 1 in channels. That's only a 6-inch difference. Again, precision for a contractor that just really isn't necessary. And then we've added 1.5 turns at the top and bottom of both column and drilled shaft spirals, and that's actually to satisfy ASHTO. So we did that. You'll find the column on your bench sheets, and you'll find that the drilled shaft spiral is already implemented on the FD standard sheet. And lastly, on column, this is just column spirals. We've increased the pitch, or I guess you could say decreased the pitch, from 6 inches to 3. And this is based on a study we did looking at the vehicle impact provisions in the design manual that Jamie actually had quite a bit of information on. We were able to satisfy those shear planes and provide enough capacity just by reducing the 3-inch down to 3-inch pitch. Now, this is only for a handful of column sizes, starting with the 36 and going up. And if you caught in there that you can't use anything less than 36-inch column on grade separations, this is why, exactly. We could not get the numbers to figure for vehicle collision on anything less than a 36. So that's why that new design provision is in the manual. So again, I said small changes, we had a big impact, and this is really the guiding principles of why we made these changes on the standard drawings, both design and detailing, to get our latest design provisions implemented, to improve the durability of bridge decks, to reduce the engineering and detailing time for those of you that are regularly using corrosion protection measures, to reflect actual construction practices, the bar spacing, the placement of PCPs, keep up with industry standards. And lastly, and this is really the big one, no undue burden of precision on our contractors. Make sure the design satisfies the design, but is practical to actually build. So that is all I have. So at this point, questions for Jamie and or myself.
Amy, did the reduced transfer steel quantity result in the shortened overhang on the transfer top mat?
I missed the very last part of that question.
Did the reduced steel quantity of the transverse mat result in the reduced overhangs on the beam on the slab design?
No. The question was, did the reduced transverse reinforcement in the bridge deck, was that the reason for reducing the length of allowable overhang? No. The overhangs were they reduced? I thought they were reduced just slightly for the text girders. I don't believe it was a significant reduction, Rob. But the overhangs with the number 4s at 9 now require to have number 5s at 9 inches, so there's a bar placed in between just for the overhang, and the quantity, the area of overhang reinforcement actually has gone up by just a fraction in the new empirical deck. Will there be a memo put out summarizing these changes? No, I don't believe we will. When the text girders are ready to be posted and they're at home back in the office being prepared right now, I will be putting out a memo that does detail a few of the things in there, but all of the detailing changes that I talked about are already captured in the bridge detailing guide, and of course the bridge design guide, I believe, is a week, days, very, very close to being posted also.
Will these presentations be available? Will they be posted for download?
Will the presentations be available? I believe, yes, they typically are posted after short course concludes.